little trick in there. I say it's a trick, but it's a way of using the packaging facilities to allow us to manage how systems are maintained and updated. Right, optional. This one's like a require, but it's optional. If the package is installed, then it must be at this version. If it's not installed, don't care. So, not having a version associated with this doesn't really make any sense, because if you don't have the version there, it's not going to work. So this one says, if we have Perl installed, it is going to have to be at this particular version. Yeah? If it just said, if Perl is installed, well, Perl's installed. It's not actually asking about the version. So it's saying, if Perl is installed at that version, then, sorry, if Perl is installed, it must be at that version.
Or creator.
Yeah. Conditional. So this is one where it's like, I'll go through a line here actually. So this one says, if runtime TK8 is installed, then, well, that must be installed for this package to be successfully installed. So effectively saying, if that one is installed, we must have that. So it's making sure you've got package pair there. Origin. This one is slightly interesting. Again, we use this facility for doing the upgrades from Solaris 11 to Solaris 11.1. What this says is, prior to installing any other packages on the system, the package in your image must be at the version specified or greater in the image that's being updated or being installed to. So, okay, what does that mean? So, when we had Solaris 11, we were quite happy delivering stuff. We had Grub 1. Okay? We moved to Solaris 11.1, we had Grub 2 come along. In order for Grub 2 to be able to use the system, we had to have a special mechanism of updating the Grub menus. We provided the transitional commands that allowed to convert a Grub 1 menu to a Grub 2 menu in SIU 10. This little bugger here. So that meant, in order to go from 11.0 to 11.1 on an x86 system, you had to transition through SIU 10, or the intermediate package updates if you're using the release repository. So that means we had to tell people, in order to upgrade your system, you need to have installed on your system SIU 10. Hence, we then had the origin dependency, which says, this system must be at SIU 10, i.e., you've got to be running this package version. Does that make more sense? So it's basically enforcing a buddy hop on you. And you note we haven't actually gone full fMRI. We don't care about anything else. So the minimum you have to have was SIU 10 there. Group dependency. So basically, this describes the functionality of a system. So we have Solaris large server, Solaris small server, Solaris desktop. And basically said, these group of packages deliver this type of functionality. And that's what it says. So it's just a single image target. So if you want to install Solaris large server, install Solaris large server, it installs all these packages. But note, it's not a required dependency. It's not saying they have to be installed. So if you then say later, I've installed Solaris large server and actually I'm not interested in GNU tar, I think the Solaris tar is absolutely brilliant, I'm happy with that, so I'll get rid of GNU tar because that's rubbish. Then you can just remove that. The act of removing it puts that package on what's called an avoid list. So whenever you then come to update Solaris large server, it will never add that back in again. You can get it off the unavoid list by using the command, what's the opposite of avoid?
Include.
No, unavoid.
Install.
So you can do pkg unavoid the name of the package, then it puts it back in and allows you to install it again. Parent. This is an interesting one. So zones. So we all know about zones. Happy about them? So we have a single image kernel, we've got software talking to that kernel. We've got to make sure that the software we have in the zone is compatible with what's running in the global zone, which is therefore compatible with the running kernel. If we don't have that set there, we could be running some arbitrary libc or something, and applications in the zone will just break because you have different command line function arguments being passed to the kernel, it just all falls over in a heap. So what we've got to do is ensure that the software inside the zone remains consistent with what is in the global zone and thus the running kernel. And we enforce that by a parent dependency, which is that puppy. And this says, I have a parent dependency on myself. The important bit is the self bit. The rest of it is just a naming hierarchy we have there. So essentially, all the packages that we have with this make sure that they will stay in sync with what's in the global zone. There are packages that don't have this, for example, the Java ones. We don't care what version of Java is running in the global zone and what version is in the non-global zone, independently update them. And that's actually quite an interesting one, because what that does is actually constrains the full fMRI. And that actually became important to us when we're delivering IDRs. So I'll talk a little bit about IDRs later, because we use all these facilities. But that's an important one. So remember, you generally don't need to do anything about it, but just remember why it's there. Incorporate dependency. So my experience talking to the engineers within Oracle, this is the hardest one to understand, hence why it's last. Incorporate dependency doesn't deliver any software. That's the hardest concept I found talking to people. It just says, I have a dependency on this package at this exact version. It doesn't cause that package to be installed. And I'll re-say that. It doesn't cause that package to be reinstalled. To be installed, not reinstalled. So, what we have here, in this example, we say we've got the OSNet incorporation. It says, I have an incorporate dependency on PPP dump at this version. It doesn't actually cause it to be installed. I'm belaboring that point, by the way. It doesn't cause it to be installed. It just means that when you come to install that package, it will be installed at that version and at that version only. You can't do anything about that. And same with all the others. And that's actually a very, very important concept to understand, because it does help with the error messages when you violate a incorporation. Oh, right, my incorporation, that's because the incorporation says you need this version. If I can't find that version, well, there's something wrong with your repository then, because you haven't got the right package version in your repository. And that's typically what we see. So we happy with incorporation?
I guess the question is, why would you just force the install because you don't have software? I guess that's the thing. Because you say, why don't you just make it dependent so you install the software, but you're saying...
Well, what you can do, you then mix and match your dependencies. So if you say, I'm going to install the system and I want it to be at this thing and I must have that package installed, you then have another dependency which is this package, forget the version number, we don't care about that, with a require type, which is exactly what we do with the Oracle Solaris. So you can mix and match all these dependencies to give you a fine-grained thing. So in order to say, I want to install a package at a maximum and minimum version, specify an incorporate dependency followed by a require dependency. Okay, are you happy with those? Yeah? Okay. A note. So I sort of alluded to this earlier. Dependencies can include some or part of the version string. So example here, I've messed around with that one we had earlier. I put a required dependency on PPP dump, but only at 175.1, which is actually just the Solaris 11.1 version. So I don't care about any bug fixes or anything like that. That can be quite happily updated later because the bug fixes are at the version string down here. The following packages, so if I try to install any of the PPT dump packages, I could pick out either of these two. Both of these satisfy that dependency because they both have that version, and those numbers we don't care about. For interest, that one is Solaris 11 Update 1 SIU 10. We haven't done SIU 10 yet. This is Solaris 11 Update 1. I'm not allowed to talk about that number actually. So that should be a 2. That should be a 0. That should be a 2. Okay. There's a reason why we have that 0, but I won't go into that. However, these following ones do not, because this is Solaris 11 Update 2. The 2 there obviously doesn't fit there, so those versions won't be installed. Okay, does that make sense? Yeah? So, some advanced bits. Variants. So we spoke about spoke about. We spoke earlier about architecture, so we've got Spark x86, obviously defines that this file is for Spark or this file is for x86, whatever. But we also have other ones called variant.debug. What you might not know is when we build Solaris, we build a debug version and a non-debug version. The debug version has got lots of symbol stuff in it, extra code in it. If you put it on a machine, it will run slower because it's got debug code in it. What you can do is if you look in the repositories, we actually ship the debug stuff in the repositories as well. So if you did want to play with the debug stuff, you change your variant, set your debug value to true, your system will then go, download a gazillion files because they're all different, because you change it to debug, every file will be different, and it will install the debug versions of those files on there. Something to play with if you want to. This one's interesting, variant OpenSolaris.zones. So we talked about zones. Zones have software in them, we have global zones. We might actually say that if we have some software in a global zone, we might not want it to be installable on a non-global zone. If that's the case, we just set it to have a variant of global. By default, it has both. If we just wanted it to be installable in the non-global zone, I can't actually think of an example why you'd want that, then you'd set it to non-global zone. Okay, so that's variants, facets. So actually, variants they have properties of what components can be installed on your system. x86 Spark, debug, whatever. So install something. Facets are an optional component. So you might say, I've got this big package. It has we use it for locales actually. So we've got all the locales. So if you're in Germany, you might want to have all the German files. So you set the locale facet to be Germany. So essentially defines what optional things you can install. So we have used it for locales. We use it for another thing called unlocking. I'll go through that. That's an interesting little trick. But effectively, it's an image property. So when you do PKG change facet, it's going through each and every package. And actually, I'm changing this facet. Does it apply to that package? So it's not a package level property. It's an image level property. So that's why it has to go through each and every package. It also means when you look at a system, you can say PKG change facet. Pete's a really good guy, facet. That doesn't mean anything to any package, but it's actually an image level property. But it still go through each and every package. And it says there, the package is only affected by facet if the value of the facet is set in the package. It has to be part of the package manifest. And here's a example. We have facet develop true. What we do deliver, the reason why this one's interesting is because this one's actually a lint library. So what you don't generally want in your system is just lint library craft, because you only use that for when you're building and doing lint checks for your library. So you might not want to set that. So if you set it to false, then it'll go off and install. Actually, no, it's the other way around. That one does get installed by default. So if you don't want to install, set it to false and it will uninstall them. Odd. And then you also see this is debug. So if you've got debug stuff turned on, then you can actually have it installed as well. Okay. Facets. So facets, one of the things we can do with facets is unlock a package from its incorporation. So one of the things we like to do with Solaris is actually have everything on a nice, well-defined surface. We've tested all these software combinatorics together. And that's brilliant for the kernel and all the stuff that interacts with the kernel. And on the whole, it keeps you on a well-defined surface stuff we've tested. But however, you might say, actually, we've got all this FOSS stuff, we've got some key system stuff we need to change. So one of the things might be saying, okay, there's been an update to OpenSSH or OpenSSL. I need to update OpenSSH and OpenSSL without having to reboot my system, i.e. take the new SRU that delivers a new kernel. So what you can do is unlock that package, which what that does is actually disassociates it from its incorporation. The incorporation controls the version of software on the system. If we unlock it from that incorporation, it means it's no longer playing under the incorporation rules, which means you can just update it to your heart's content. So in this case, all the FOSS components have these set on them. So you can look at PKG facet lock. It's got a bit of a long name to it. It's facet version lock, name of the package. If you set it to false, then that package is no longer part of the incorporation. You can then update it to whatever version you want. The next question